Okay, so we have another interesting puzzle here today. It's called Regional Heatwave, and it's by ThePedallingPianist. So let's have a look at the rules. Normal Sudoku rules apply. Classic fog of war. Some of the grid is covered in fog. Entering a correct digit will clear all fog in that digit's immediate neighborhood. Now, regionometers. Box borders divide lines into segments whose sums must strictly increase from one end to the other. No line has multiple segments in the same box. I'm not sure I know what that means. Because this line, it looks like it... multiple segments in the same box. Okay, sure. So what it's saying is that this line, for example, it can't go here and then come back into this box, right? Because that would be two segments in the same box. Different lines are different colors, and lines may not branch or share cells with other lines. Lines may cross diagonally at cell vertices. So this line going here, we could have another line that went like this, and they would not be sharing any cells. In B, lines have been made thin enough, such that it is not possible to assume that diagonal line segments do or do not exist based on a few pixels of color in the corner of a non-fogged cell. So, for example, row 5, column 1 to row 6, column 2, row 6, column 2, right? May be a line segment. So it's just saying that that if a line went through here, like this, I can't assume that I would be able to see, I know that I would not be able to see the corner of a piece of line showing through the corner of the non-fogged cell like that. Okay, so regionometers. Okay, so let's get started. I think we'll draw. I think we will draw a little bit to help complete our lines. So we know. So different colors, different lines are different colors. Okay. So that must mean that this line and this line, it's the same line. And this is going to be a fairly large line that crosses, 1, 2, 3, 4, at least 5 boxes. At least 5 boxes. And then this pink line, I think we know for sure that it only crosses 3 boxes. Because we know it comes out of this box and it goes into this box. And if it left and then it begins and terminates, we can see where that happens. Now, we don't know in what direction it's going to be increasing from one end to the other, whose sums will strictly increase from one end to the other. So I don't know. I don't know which is the end, which is the bulb and which is the tip, basically, of this line. But because I know that it enters this box and leaves this box over there, I know that it can't exit this box and then go back in and come out, because then I would have more than one segment, right? But what I don't know for sure is that it does that. Because it could do this, for example. Well, this is quite interesting. Another thought I'm just having is this line, for example, and this line. It's kind of symmetrical. This has to occupy at least 3 cells in this box, because I can't go back into this box, box 4. I have to go either into box 5 or box 8. And to get there, I need to use up at least 3 cells. And same for here. I have to go into box 5 or box 6. This one, I don't know if I use 3 cells. Well, actually I do. I think I do know I use 3 cells, because the segments over here is 1 cell each. So the most this can be is a 9. Oh my goodness. I don't know if I should restart the puzzle or just keep going, but let's pretend that I didn't place a big 9 in there and accidentally reveal the fog with a correct digit. I should have placed a small 9. So let's see here. Now, big rookie mistake. So the point that I was getting at was that this can't occupy 4 cells, because then my minimum sum would be 10, and I can't make a 10 with 1 cell. So this is at least going to be 6 that I have in here, which makes this 7, 8, or 9. And it is, well, it doesn't have to be 3, it could be 2 or 3 cells. So it can occupy these cells. 3 out of those 4 cells. Let's pause that. So, I mean, this doesn't seem very constrained, this pink line, because I think this red line is going to be a better place for us to start, because we know that we're covering at least, what did we say, at least 5 boxes. And we know that the first, well, yeah, I mean, we know these are only 1 cell, and we know these are 3 cells at least. Although it's not going to be more than 3 cells for the same reason that I talked about here, which is that because I have a 1 cell, I can only ever get to 9, and 4 cells would exceed that limit with 10, the sum of 4 cells. So yeah, this one, I mean, this could be, this could be anything up to 7, basically. 7, then I can make these 3 equal 8, and then I can have this be 9. So let's think about this. Well, if it crosses 5 boxes, and okay, well, this one I think we actually do have a digit. We know that one of these has to be a 9, because I don't know which side is the bulb and which side is the tip. But I know that when I start, my second segment sums to at least 6. So let's say 5, then this would be 6 with 3 cells, 7, 8, 9, and that's the shortest path. So one of these isn't 9. By the way, this one, I made a mistake here. 7, 8. We don't know that's 7, 8, 9, because we don't know the direction of the thermometer, the regionometer. So we don't know which side is the tip. I just don't understand how I would figure out which side is the tip. Anyway. No, that one of these has to be a 9. And the other one just has to be less than 6. And what I also know then is that it has to go take the shortest path through, like this. So it goes through this box 5. Which means it has to enter through here. Because that's the only way I can get to box 5 without crossing this. And if it crosses this, I have 6, 7, 8, 9. And I've gone bust. So I know the line is going to have to do that. And I know it's going to have to do that. Inside here, it must also cross 3 cells, which means it has to do that exactly. If it goes any other way, it's going to occupy more than 3 cells. But over here, we don't know. It could do something like this, or it could do that. So that's 1, 2, 3. That's 1, 2. Now, I don't know that because I don't know which side is the bulb. Okay. So one of these sums to 6. One of these sums to 8. Okay, here's the thing. This one sums to 7. And there's only one way to make 7. And that's 1, 2, and 4. Okay. And now we've put big restrictions on this, on the sum of this segment for the pink line. 6, 7, 8, 9, 7, 1, 2, 4. So, but that does not seem right. That's impossible. Lines do not share. Yeah, well, I have a problem here. 5. So because I just can't make. But I can because this doesn't need 3 cells. It can occupy 2 cells. That's the solution. It forces this to occupy 2 cells. And now I make this 3 and 5, which is 8. And now one of these is a 9. But how do I figure out which is the 9? That's just what I don't understand. I mean, to me, this puzzle, it's very symmetric in a lot of ways, right? So one of these sides is a 9, and one of these is a 9. If this is the 9, that's the 9. And one of these adds to 6 with 1, 2, and 3. I can put that either spot. This is a 9. That's the first digit. Because I can't put a 9 here any longer. So 9 in box 5 goes there. Okay. And we reveal more clues. So let's draw this. Let's draw that. Let's draw that. Okay. I suppose I'll just draw kind of over the whole line just for consistency. Okay. So this is the tip of this line, which means that this must be the bulb. Now this crosses at least 3 cells, and remember, we know already, it cannot cross more than 3 cells. So this is going to occupy 3 cells. 6, 7, 8, 9. Okay, and then we've kind of hit critical mass, and we know that this is going to be an 8. This is going to sum to 7, and this is going to sum to 6. We just don't know. Well, we know this. No. We know they can't share cells, so. Well, I think we know this one has to go there, right? Because if this line went there, then I can't get to box 4 without occupying another cell and making it a segment of length 4 in box 1. So it's going to have to go down. But now I just don't know if it goes there and there, or if it goes here and there. This green line cannot come back into box 4 because then it will be multiple segments in the same box. Whoops. And we can see it's not over here, and it can't occupy any of these shared cells, so it has nowhere else to go other than there. So this is going to be a long segment. Okay, and then it's coming there, 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 and there. From here, we don't know. It could go there, or it could be a very long segment that goes all the way around there. That would make it length 5. So it's either length 4 or length 5 segment in box 1. Okay, so this sums to 7. This is going to sum to 6. 1, 2, 3. 1, 2, 4. So this, no, I was going to say this becomes a 4. That's not true. 1, 2, 3, 4, 5. So has this sufficiently limited, this hasn't yet revealed which side is going to be the tip and the bulb for these cells. The maximum sum of this is getting a bit limited because I can't use 8, and I know one of these is going to be a 9, so I can't use 9 either. So the maximum I can do is 5, 6, 7, 6, 5, and 4, which just makes me wonder if this can be length 5. given that here I can't use 1 or 2 or 4, so I've got to do, well, let's just work it out real quick. The minimum that this can be, if it's length 5, 1, 2, 3, 4, 5, it's going to be 3, 5 gives me 8, plus 6 gives me 14, plus 7 gives me 21, plus 8 gives me 29. It's 3, 5, 6, 7, 8. 29, and then if I, what's the most I can make from 4, 5, 6, 7? Well, that's less. That's just definitely less. Let's just work it out. 4, 5, 6, 15, 7 is 22. So this can't be of length 5. It's going to have to be of length 4. It's going to have to do that. That's the only option. And then our maximum and minimum are actually very close. What did we say? We said, I can't remember what we said, but we said this will now have a minimum of 21. And this has a maximum of 4, 5, 9, 15, 22. But, okay. Well, this is the bulb, obviously. I've just realized, because these sums are going to go very high. So that's the bulb. So this, but then that's perfect. So this has to be 21, and this has to be 22, because I forgot that it has to be increasing, not the same. So this is 3, 5, 6, 7, right? Giving me 21. And this is 4, 5, 6, 7. Giving me 22. And then this is an 8, 9 pair. 4, 5, 6, 7, 8. I still have my 9 reserved. Okay. And then this can be basically anything. Wait, we said one of these has to be the 9. So this is the 8. And that is the 9. And now we have this 9. Okay. Very good. And we have this 9. Big breakthrough. 5, 6, 7. Okay, let's just see what is going on here, because we've revealed quite a lot. This we said has to be of length 3, so it needs to connect there, and that one needs to connect there. This green one still goes, so that's going to be big. This one connects through there. So this is 1, 2, or 3. Okay. This can be anything less than 8. Okay, so this is anything less than 6. It's going to be 1, 2, or 3. This is going to be 1, 2, and 3. Now we've got to have a lot of pencil marks to manage. This is 6, that's 7, this is our 8. How do you make 8? 1, 3, 4. It's 1, 3, 4, 1, 2, 5. So we don't know much about that. 1, 3, 4, 1, 2, 5. I think all are possible. So we just know there's a 1 there. Now we have over here 6, 7, and 8. One, 2, 3, 4, 5, 6, 7, 8. We need a 9 here somewhere. We know the position of the 3. Because if this were the 3, I'd have a 1, 2 pair, and then I wouldn't be able to sort these ones out. So that's the 3. So that's not the 3, which means the 3 is there, which means that's the 5. That's the, whoops, that's the 3. Wait, what did I... Whoops, I took out the 4. I meant to take out the 5. One, 2, 3, 4, 5, 6, 7. Three is up here, so that's not the 3, that's the 3. Okay. 3, 1, 2 pair. 1, 2, 1, 2, 4. So 4 is here. So 4 is not there. That's a 1 or a 2. Can see more of our gold line going through here. That's a 6, a 7, or an 8. And that's a 5, a 6, or 7. What is that telling us? But hang on, I don't know if I was done with my Sudoku. I think I am, actually. I think I'm done with the Sudoku. 7, 8. I mean, this... What is this green line doing? Because this green line needs a lot of space. And it's running out of spots to go. It doesn't go there, and it doesn't go there. It could do that, but no, it can't do that, because this is at least 7, because 3, they're all seen by 3s, so it can't be 6. This is at least 7. So then this has to be 8, and this has to be the tip, right? Because if that's at least 7, then it can't go that way. Okay, so we actually get something. Ooh. Maybe not. But this, sorry guys. Yes, of course. This gold line can occupy more spaces. Of course, of course, of course. Of course. But I think we still know that this is 7. Because think about it this way. If it was any more than 7... No, it doesn't have to be 7. What am I saying? It doesn't need to be 7. It can be more. This can be 6. This could be 20. I mean, we just don't know about the gold line and the green line. That's what I wanted to think about. Put in a wrong digit. Wrong digit. Need to be more careful. I'm just going to pencil mark this in. I know it's kind of a nasty pencil mark. But that's 4, 5, 6, 7, 8. And one of them is definitely 8. 1, 2, 3, 4, 5, 6, 7, 9. So I just wanted to think about the gold and the green sum. Let's think about the green a little bit, because now this has to add up to at least 23. So if this were to only take up 3 cells, so if the green were to go there, for example, and then stop, the most I can make is 7, 8, 9, which is actually pretty good. Right, that's going to be 24. This is a bit tricky because I could... I wish I knew a little bit more information about the position of these 4s and 5s and 6s and 7s. 4, 5, 6, 7, 5, 6, 7, 4. So we need this to add up to at least 23. So then, maybe I must think about the gold line. If the gold line did terminate there, well, we know it can work because I can do 5 or 6, and then 7, and then 8. Five, 6, 7. Yeah, so we don't know that the gold line has to take up another cell. And if our green line took up all 3 cells up there, then it could be composed of smaller digits like 4, 5, 6, and 8. No, but yeah. Well, it has to take the 9. It has to take the 9. I'm not sure I'm thinking about this correctly. So 7, 8, and 9 gives you 24. So I have a wiggle room of 1, basically, right? Seven, 8, and 9. So I'm just thinking about the math. So 7, 8, and 9, I can sacrifice 1. So I can't give up the 9. So 6, 7, 8 is going to be too little. So I have to take the 9. And I think I have to take the 8. And then I could do 6, 8, 9, right? And is that the only other valid combination? Six, 8, 9. It's 6, 8, 9 or 7, 8, 9. And then if I do 4 cells, the only 4 I can do are those 4. Well then, could I do 4, 5, 6, and 7? No, I can't, because that's what I did here. But I could do 4, 5, 6. Well, I need to take the 9 if I take up both of those cells. But I mean, you know, if the question is, well, can I make more than 23 with 4 cells? I mean, yes. But I'm just thinking about what my actual combinations would be. I would take the 9, I would take the 8. And any of those two. I mean, I don't see how this is going to help me very much. Because wait a second, I can't make 7 here. Because 7 would look like this. And now I've got 1, 2, 4. Spread up 4 cells. So actually the least I can make is 8. 1, 2, 5. Or 1, 3, 4. Well, not 1, 3, 4. 1, 2, 5 would be the lowest, and that's 8. Okay. So now we have a problem. So that's what I needed to pick up. Because now, if I do 8, I don't have a number that is higher than 8 on either side unless this grows. So if the minimum I can make here is 8, then this cannot be the tip of the bulb. This is the tip of the regionometer. This is the bulb of the regionometer, and it's a 6 or a 7. This does not have to be 8, right? But because I know that the minimum is 8, I know that the gold line must extend up, at least until there. And then the green line has to go there, because I need at least 3 cells for the green line. And the 3 cells, well, now I know this is an 8. Because I know that this green segment needs an 8. And it needs a 9. But then we said it could take either the 6 or the 7. So we said 789 or 689 works. Here's the 9. So this is the 9. Yes, this is the 9 and the 6 or the 7. Yes, and then this is definitely the 4 and the 5. And the 6, and then either the 6 or the 7. Okay, so my minimum here was 8. 1, 2, 5, like that. So that's the bulb, and then this just has to equal at least 9. So even if I did the minimum, which is 4 and 5, that would work. So I'm not sure where to go with this now. Well, 5 is, no, we didn't show that. 6, 7, 9. Ah, we showed that 4 has to be here. Which means 4 has to be here. Okay, very good. Yeah, but 4 just really doesn't help that much. 5, 6, 7. 4 is down here. Because I can still do just 4 and 5. All came out from there. 1, 2 pair. I'm thinking about lunch. All right, let's keep going. So we're making good progress, slow and steady. But I think we've hit maybe a bit of a roadblock. 4's here, 3's here, 9's. Wait, what's going on here? That's supposed to be 9. 9's, 8's. 6, 7, 8. 8's out of there. 8's here somewhere. Okay. This can be anything. 8. This, again, it can be anything, right? We really don't know much about that. 2, 3. Yeah, I don't think we know anything about that that's going to help us. Eight, 6, 9. Yeah, I'm not going to check that again. I know 8, 6, 9 is 23. 8, 7, 9 is 24. This is 4, 6, 15, 22. So we really don't know if it's a 6 or a 7, and we don't know what to use here because let me just think. 5s. 5 can go. Oh no, 5 can't go there. We said 5 can't go there because 5 does not go here, so 5 goes here, so 5 does not go there. 1, 2, 4, 5, 6, 7. Okay. So 4 and 5, I have 9. I can make this as low as 8. Right. I'm gonna check it one more time. I do 1, 2, and 5. 1, 2, 3, 4. Sorry, 5. 1, 2, 3, 5. That has to be the 5. Ah, no, but that doesn't work. No, it doesn't work. Yeah, it doesn't work because this one would. Oh well, that one can't even be 5 actually. And then once I've used a 1, 2 pair, no, that won't work. That won't work. Okay, so 1, 1, 2. I mean, I can't put any of 1, 2, and 3 here. Sorry, I'm being a bit slow. I can't put any of 1, 2, and 3 here. So the least this can be is 4. And then up here, I can't have 1, 2. 3. Yeah, this is a fairly large number actually. 4. 1 and 5. That's the lowest I can. The lowest I can make is 10. 1, 2, 3, 4. I could put a 1 there, and then I could put a 5 here. I mean, I can put a 5 and 1. I'm just checking that. I can't do 1, 2. I can't do a 3 anyway. I can do 1. I've used a 4. So 1 and 5 is the minimum. Okay, so that's 10, and then therefore I need this to be a 7. Simple as that. It's simple as that. I can't make this number any smaller. I can't do it. No, I'm convinced. So this has to be the 7. Good show. And then this, I think, will be 1, 4, 5 to give me 10. This can still be 6 or 7. That's not 7. That's the 6 and the 9. So that becomes the 5. And at this point, I'll take away the pencil mark for the 9. 6 and 7. 1, 2, 5. That became 6. Which means that is 5 and 7. Okay. Looks good. Okay, so I just need to think this through. So that can't be 5. Okay, and then if I put a 6 there, the number's going to be too high. So this has to be a 4. 6. 1, 2, 4. Okay, that's a 4. And then this has to be 1-5 pair. And we know the order, but I'm just double checking this because I'm almost just not believing myself. But if I can't do 1, 2, I can't do 3 anywhere, I can't do 4 anywhere. So the best I can do is 1 and 5. Make that the 4. That's a 2. That's a 1 or a 4. That's a 1, 3. That's a 2. That's a 1. And the fog's clearing. And I think we have basically made a really good breakthrough. It's still 2 or 3 up there. Okay. Okay, I think that's where it ends. Okay, so let's start having a look at this line that goes there. I don't know why, but I'm having this suspicion that I'm missing some Sudoku somewhere, but I don't think so. 6, 9, 5, 7, 2, 3, 6, 5, 6, 7. I think we're pretty good. I might quickly check. Yeah, I knew it. I knew there was something. There we go. We get the 3 and the 1 there. So what is this? 6, 7, and 8, and 9. Ah, but we have the 6, 7 pair right there. So that's 8 and 9. Cool. And up here we have 1, 2, 3, 4, 5, 6, 7, 8. 6 is not there. 7 and 8 is not there. So that is the 6 actually. So we do make a bit more progress. Six, 8, 9. This one, 7, 8, 6, 7, and 4, it looks like. And down here, well, yeah, that's not very clean. That's annoying. So right here where the line starts. What about this one? We didn't complete this yet. This had to be 8. So 1, 2, 5. Or 1, 3, 4. Okay, well the 1s came out there, forcing that to be the 1, which is good because I had a 3 and a 4. Well, I had a 2, 3, and a 4. 1, 3, 4, 1, 2, 5. Well, actually, okay. So this is. Oh, we don't know what this is, but it's 3, 4, 2. It's taken from 2, 3, 4, 5. That's not very helpful. One, 2, 5. Or 1, 3, 4. 3, 4. Or 2, 5. So this will never be a 5. And this will never be a 4. So it's going to look like that. Seven, 8, 1, 3. Seems pretty good. 1, 2, 5, 1, 2, 4. Okay. Now, what's going on here? So we have a 2 cell and we have a 1 cell segment. Then we have 4 segments in total, where these could either be 2 or 3. Well, this could be 1 cell as well. This one is at least 2 cells as well. So 6. Okay. No, 6 actually. 6 is just high enough such that I could make this sum to 7, and then this sum to 8, and then this sum to 9. It's kind of annoying, isn't it? Actually, we can fill these in based on the box. 1, 2, 3, 5, 6, 7. Okay. Wait a second, something's not right, because now if I take out 7 here, I have a 6-8 pair. Wait a second, what have I done? 1, 2, 2, 3, 7, 4, 6, 7, 6, 7, 8. I've done something wrong, and I'm not sure. I'm not sure what it is. 7, 8. Well, I've put 6, 7 here firstly when I have a 7, 8 pair, which is a bit strange. 1, 2, 3, 4, 5, 6, 7, 8, 9. This can be 7. But I said it can't be 7, I suppose, because I have a 6, 7 pair. 6, 7, 8. Yeah, I've just done bad pencil marks. Wait, but this, I think we said it can't be 8, based on the regionometer. So why am I... No, but it can be 8, based on the regionometer. Okay. Let's just be a bit careful about what I've done here. Let's just be a bit careful. 6, 7, 8, 9. That cannot be 8 or 9. And it can't be 7. So that is the 6. Okay, let's just put that in. Then I have 7, 8, 9. This is 10. And this is 11. This is the bulb. That can be 7, 8, or 9. But it's not 9. It's 7 or 8. And then this is... not 7 or 9, that's 8. And then making that a 7 and making that a 9. Okay, so I'm not sure what I was thinking about when I did those pencil marks, but it was obviously not correct at all. 4 and 6, 7 and 8. Okay, I think I'm happy with that. 4 and 6, then we take the 6 out of this. This is... What the heck? 1, 2, 3, 4, 4, 5. 1, 2, 3, 4, 5, 6, 8. Okay. We fixed it. And it's all sorted. So 6, 7, 8, and 9. So that's possible. So this is going to be the bulb. This is going to be the tip. No, I'm wrong. Because this could be 5. This could be 2 and 3 giving me 5. And then 6, 7, and 8. Oh, so it can actually go either way still. 6, 7, 8, 9 with the 7 and the 3. Or the 7 and the... Well, sorry, with the 7 and the 2, but it could also be the 7 and the 3. It doesn't have to be consecutive, remember. Okay, so let's think about the case where we go 6, 7, but we don't have to go 6 and 7. Let's think about this case, which is more restrictive, okay, where we go 5, 6, 7, 8. Because if this is, if the regionometer is going that way, such that, you know, this is the bulb and this is the tip, then we're going to have to do 5, 6, 7, 8. Right, the more constrained case is the one where the tip is the one cell region or segment. So 5, 6. So I would need this to be 3 cells. Now I'd have to put 6 over here, but that's impossible because it's seen by ones. And if I go out this way, I would have to make 6 from at least 4 cells, which is impossible. Okay, well that was quite easy. So this is not the bulb. This is the tip. And the tip, the largest we can make is 10. So this can't be 8, and that is 6. And it looks like we're going here. Now it could still be 3 cells. So we just have a little bit of wiggle room. Oh, but this is 1 cell. Okay, so that has to be an 8. That's an 8, and then this is a 9, and that's a 10. So let's complete this. That's going right there. This has to sum to 9. This has to sum to 10. So that's going to be the 3, 7 pair. 9 from 2. Let's see, what can we do? 5, 4 is out. 8, 1 is out. 7, 2 is doable, like this, and 6, 3 is also doable, like that. Then we would have a 3 here, 7, 6, 3, 7, 2. So what are these 2 cells? 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, we might just kind of play a little Sudoku or something at this point. One's down there, one's here. Twos. That became a 5. Just by the way. 1, 2, and 3. Six. Um, 7 and 3 goes that way, actually. It was based on that. So, okay. So now we have to do 7 and 2. Like that. That's a 4. That's the 3. 5, 4. 7, 5. 8, 7. Let's keep doing our drawing. Not super helpful when it only goes through 2 regions. This looks like we've got 2, 9, 6, 8 right there. And then this one is 1, 2, 3, 4, 5, and 7. Yeah, we just have to place some Sudoku down here or what? I mean, this is not very helpful. I mean, yeah. Yet to be determined. Three, 4, 5. Okay, so that's the 5 actually. Wait a second, what did I do there? Yes, 1, 1, 3, 5. That's the 5. A 1, 3 pair is nice. One, 2, 3, 4, 5, 6, and 9. Probably this is going to be the tip. I'm just guessing. So 1, 2, 3, 4. 4s, 6, 7, 8, 9. 2, 4, 6, 9. That becomes a 2. That becomes the 4. That's gonna have to be the whoops. No, we already have a 4 in that row. 6, 7, 9, and 5. Not the best pencil mark ever. Two can still go down there, so 2 doesn't have to be here. Why do I have 4, 8 written here? That's 8. That's 4. Makes that 6 and that 8. So that's obviously 5, 7. 7 actually. 5, 7. 9. So 7, 9. That's 5. That is 6. 7, 6. 2 or 3, 9. 6, 9. So what's going on down here? We have 10 on one side. So the other side, it just can't be 10. Is really the only information I have. So I can't have 2 and 3 down there. So that is going to be, sorry, the 1, 3, 1. Well, what am I doing? I can't have 2 and 3 down there. So that's the 3. 1, 3, 2, 3, 2, and 1. Good show. A bit over an hour. We kind of, I don't know, got hung up a bit on the Sudoku, but really fun puzzle. So good show.